Alright, so welcome to the next section of the SAT Math. Today we're going to cover Test 5, Section 4, question from uh, 25 to 28. So the first in question 25, we can have a metal ring with two surfaces, and the thickness of the rectangle box is 0.5 centimeter. The surface have a square faces, and each side has a side length of 2.5 centimeter. Also, in the box we have a hole with a circular shape with a diameter of 2 centimeter. So they ask, what is the volume of the metal to form the ring? So to calculate the volume of the ring, we can see that the volume of the ring is actually the volume of the rectangle minus the volume of the cylinder. So to calculate the volume of the ring, we have to calculate the volume of the rectangle first, and we minus it and then we subtract away from it the volume of the cylinder. Okay. So first of all, let's calculate the volume of the rectangle. Uh, of the Okay, so the volume of the rectangle is just simply the height times the width times the length, right? So it's 2.5 times 2.5 times 0.5, and you can see that that's gonna equal out to 3.125 centimeter cube. And then we have to calculate the volume of the cylinder. The volume of the cylinder gonna be pi times, so the volume of the cylinder gonna be pi times volume of the cylinder gonna be pi times r square, the radius of the rectangle square, and we time it with the height of the cylinder. So it's pi times r squared times h, right? So here r is actually 1 because the diameter is 2, right? The diameter 2, so the r is equal to 1. So the height here is 0.5 centimeter, which is the height of the figure. So we can say pi times 1 centimeter squared times 0.5 centimeter, which is equal to 1.57 centimeter cube. And then when we have known the volume of the rectangle and the volume of the cylinder, we just subtract the volume of the cylinder from the volume of the rectangle, and we obtain with the volume of the ring. So volume of the ring is gonna be 3.125 centimeter cube minus 1.757 centimeter cube, which equal to 1.55 centimeter cube. 1.55 are corresponding to the answer B here. So the answer for 25 is B. Okay, so now we show to number 26. Number 26 answers that in the xy plane, line L go through 0, 0, and perpendicular to the line 3x plus y equal to C. 3x plus y equal to C, where C is constant. Okay, and these two lines, line L and 3x plus y equal to C, intersect at the point K and K minus 4, and they ask for us the value of K. So first of all, we're gonna consider that the line L go through the original, which is 0, 0 first. So first of all, we're gonna assume that L has the form of y equal to ax plus b. Because L goes to 0, 0, we can substitute 0 into x and 0 into y to yield 0 equal to a times 0 plus b. This part 0 here, a times 0 is 0, and a times 0 plus b equal to 0, which forks b equal to 0 as well. Okay? So when we substitute 0 back into the original equation of L, we're gonna get L equal to y. L has the form of y equal to ax. Alright? The next step we have to do is that we have to transform the equation of line 3x plus y equal to c into y equal to ax plus b form. So we just have to move 3x to the right side. So we're gonna get the equation for D, which is y equal to minus 3x plus c. because L and T are perpendicular, so the leading coefficient of x, I mean the coefficient of x of the two lines has to have the product of -1. So here, I mean, is the the a here, the a here, okay, the a here and the -3 here has to multiply together to yield -1. So here we have -3 times a is equal to -1. So we can solve for a, and we see that a is equal to 1/3. So like L is y equal to 1/3 of x, because L originally had the form y equal to ax, as we have concluded here. Now we know that the point k and k minus 4 belong to L. This is belong to. So we know that k minus 4 is equal to 1/3 of k. And when we solve for k, we can see that k is equal to 6. And here, the answer 6 is going to correspond to the B such selection, choice B. All right. Okay, number 27 asks us to work with a graph. So number 27, a part delivery package for the post office. The graph above shows his distance from the post office during his delivery route, with portion of the graph represent the time when part is driving along a circular road around the post office. Okay, so we can hear that. Here we can see that okay. So the graph here consists of three straight line parts, and a circular part. So very and wrongly conclusion you can get is that this portion here is where path traveling is circular. But actually, when you think this thinking is wrong, because actually when you think about it, when a person travel in a circular motion, the distance of that guy to the center is actually not changed. So this line is R here, and this line is also R, because all the radius of a circle is the same. So when a person travels in a circular motion, the distance from the center will not change. So here, the portion of the graph that represent a circular motion is the portion of the graph with the distance from the post office doesn't change according to time. So that portion is from 1 hour to 3 hours. This portion right here. This portion I am putting my mouse here. So it's actually from 1 hour to 3 hours. So the answer for 27, it should be B. Okay? Because the distance is not changed. And you can see that in fact here 27, when you look at the answer, it's actually B. Alright, so now we have then number 28 left. A bakery sunrise muffin to weigh between 1 3/4 and 2 1/4 ounces. If M is the weight of the muffin, which of the following inequality express the possible value of M? So here, first of all, we're gonna change this number into fraction, proper fraction. So those mixed number into proper fraction. So 1 and 3/4 is translated to 7/4, and 2 plus 1/4 is translated to 9/4. Okay, so we know that the M is lying between 7/4 and 9/4. Okay, so now we subtract 2 from the both sides to get the M minus 2, and we can see that minus 1/4 is smaller than M minus 2 and smaller than 1/4. So therefore, we can know that this fact is equivalent with the inequality that the absolute value of M minus 2 will be equal to will be smaller than 1/4. So therefore, the answer is B. We can see this in a graphical representation here. When a number lies between these two lines of 7/4 and 9/4, we can see that the middle point is 2, and the middle point has a distance of 1 over 4 with both of these two numbers, 7 over 4 and 9 over 4. So therefore, if a number lies in this range, 7 over 4 to 9 over 4, the distance of this number to 2 is bounded, I mean less than or equal to 1/4. So therefore, the absolute value of m minus 2 is less than 1/4 here. So the answer should be B.